Hi there, welcome back to the channel and let's solve the problem sum of three values. In this problem, we are given with array of n integers and our task is to find three values at different positions whose sum is x. This problem is built upon the problem sum of two values, so I would suggest that you should watch that. I will link down it in the description. In this problem, again we need to find three values whose sum will become to the given target, and those three values should be present at distinct position. Clear? So, and if there is no position of the values and there is no sum of values whose sum becomes equal to target, we need to print impossible. So in the first example, we have four values and the target value is 82751, and this is the array, and I have also written down the indexes. From the previous problem, we know that we need to do the sorting operation because we need to match one small number and one heavy number, one light number and one heavy number, and we need to check. So we will do the sorting operation, and still the index are attached. So you can say for this one was having fourth index, here one is having the fourth index. Okay, so now what we were doing in the sum of two values was we were having 2 pointers, front and rear. This time we will have a three pointer approach in which we will try to log the first position and will apply the sum of two values in this section. If we were unable to find, we will increase the locking number. Let's see this with an example. And again we have front and rear pointer, and if in this section we are unable to find by taking the where the locking number pointer is pointing front pointer and rear pointer. If these sum doesn't equal to the target, we will keep on applying the sum of two values in this section. If front exceeds the rear or becomes equal to the rear pointer, we will increase the locking number. So this was too much wording. Let's directly see complete with an example. Here we have seven numbers and we need to make the target 70 numbers itself, array itself, in a sorted manner. As told, we will lock the index and will apply the sum of two values in this section. So what we need to do, we need to have the sum for this would be wherever the locking index is pointing and front and rear. So that would be 11, right? 1 plus 2 plus 8 is 11. Clearly that number is less than the target, so we will increase the front pointer. So front will be increased. Again we will do locking index wherever the locking index is pointing plus front end, where the front is pointing, where the rear is pointing. So we will do again 8 plus 4 plus 1 will be 13, which is still less, so we will increase front, and we will keep on doing this. Here it is 14, less, increase, 15, less, increase, 17, this is 16, it is still less, again we will increase, and here the sum would be 8 plus 1 is 17. But remember that we need to find the distinct position, and here front and rear are pointing on the same number, right? And that is not a distinct position, so we would not include. That means front doesn't have to run where the rear is pointing, it has to run before it. So we didn't find any set of values which can make the target. So in this section we were unable to find, so we will unlock the index and we will increase the locking index. Clearly this locking index is also a pointer, don't think of something else. I've just represented in a visual manner. Now we have the locking index pointing at the second position. Again the same thing, we will do the sum of two values in this problem, where the front will be here, and again we will do the summation. So this will be 4 plus 2 plus 8, that is 14. Is still less, so we'll increase. Is still less, 15 is less, so we will increase. Is still less, we will increase. And here 7 plus 8 plus 2 is 17, which is exactly what we are looking for, right? 17. That means sum is equal to target. We are good, we are happy. And also there is a condition, when sum becomes heavier than the target value, then in that case we try to decrease the rear because that is pointing to the heavy number. We will try to reduce it. So now let's code this up. So we need to have array of n integers, and what's the input? Let's see. So we have the n and the x, which is the target sum, and then we will have the array of, first we have the n, which is the size, and then we will have the target. Now we will have the size and target. Also we need to have the array, right? So let's define array with a given size, and let's input also. Input, this is just the input part. So while I can increase the index and can input. So this was just the input, and this should be. Then what we need to do? We need to have the container, right? Because we need to have the number and its position also, because at the end we need to have the position printed. So let's define vector only as the container. We can have pair, and this as container, as because we need to do the sorting operation later, that's why this is important. So let's fill this container also. So we have to container dot push back, and what we need to push back, the first would be the array array number and the index, right? We need to put index also. And since they are using one based index, and we are starting with 0, so they need one based index. That's why I have increased it with +1. Okay, this should not be there, I think. Yeah, now it's good. Now we have to do the sorting operation also, and this should be in pair form. Okay, now we'll do the sorting operation, and by default this will take the first of the pair. So container dot begin, and in our first position only we have the number. Okay, container dot end. Sorting operation is done. Now let's start our main sum of 3 values algorithm. We know that we have to lock. So this is the locking index, we can say locking index, which will be 0, and this locking index has to be less than the size, and this is locking index. Now the locked number would be the first, right? This would be the first pointer basically. So that would be container wherever the locking index is pointing dot first, because in first position we have the number. Okay, now we need to do the same what we used to do in sum of 2 values. So front would be pointing wherever the locking index was +1, and rear would be back. So rear would be size minus back -1. Done. And also we can have some variable because we need to do the sum operation, and this have to go while front is less than rear, right? Not equal to, because we need distinct position. So sum would be, what would be the sum? The locked number plus wherever the container front is there dot first, because in first position we have the number, plus container wherever the rear is pointing dot first, right? Then we have the condition. What's the condition? If sum becomes equal to target, we are happy. We have found one set of values which equal to target. So we can print the position. We need to print the position, right? That means we need to do the second, right? Dot second. We can give some space, and container front dot second, give some space, container rear dot second, and we can return also from here. Nothing, no need to do anything. But what if our sum is less than target? In that case we need to increase the front on, or one, if sum becomes too heavy than target, then we have to decrease the rear pointer. That's it. And at the end we need to display impossible. So I can simply do impossible. Great, right? So else, okay, right? Yes, everything seems good. Now let's try to submit this. Submit sum of 3 values. Okay, so this mistake. Okay, so it has been accepted. Great.